Your tears have a unique microscopic pattern based on why you cry. There is something happening on your face right now that you have probably never thought about. Not the emotion itself, not the grief or the relief or the strange, inexplicable weeping that sometimes arrives while watching a film about a subject you thought you didn't care about. Not even the fact that you cry, but the specific, unrepeatable, crystalline architecture of what you leave behind. Because when a tear dries, when that thin salt film evaporates off your cheek, off the back of your hand, or off a glass slide in a laboratory, in some quiet building somewhere, it doesn't just disappear. It leaves a structure, a physical record. Something that, under a microscope, looks so different depending on why it fell, that a trained eye can sometimes tell the difference between a tear cried in grief and a tear cried from cutting an onion. They look almost nothing alike. And that fact, once you know it, does something to you. It changes how you understand the body. It changes how you understand crying itself. It makes you wonder what else is being recorded in places you've never thought to look. Let's start with what a tear actually is, because most people, if pressed, would say something like salty water from your eyes and leave it at that. And while that's not wrong exactly, it's the way that a symphony is organized sound isn't wrong. Technically accurate, almost entirely useless as a description. A tear is a wildly complex biological fluid. It contains water, yes, but also lipids, fats, that form lactoferrin, which is antimicrobial and binds iron to deprive bacteria of nutrients. Lysosome, an enzyme that literally ruptures bacterial cell walls. It was actually discovered in tears before it was found anywhere else, by Alexander Fleming, the same man who later found penicillin, though almost nobody remembers that part of the story. There's immunoglobulin A, an antibody deployed quietly and constantly, a low-level defense you never feel working. There are electrolytes, sodium, potassium, chloride, which is why tears taste the way they taste. There are growth factors that maintain the surface cells of the eye. There is even a small amount of urea, the same compound your kidneys filter out of your blood. Your tears contain a version of what's in your urine in trace amounts, and your body produces them constantly without your permission. You are always in a very quiet biological sense. You are always in a very quiet biological sense, weeping. Because there are 3 types of tears, and most people have heard this at some point, but haven't really held it in their mind long enough for it to feel strange. The first type is basal. These are the tears that exist right now, coating your eye as you read this, keeping the cornea from drying out, doing maintenance work the way that oil circulates through an engine. You produce roughly 1 to 2 microliters of these per minute. Your eyes are never dry while healthy. Never. There is always a tear film. The second type is reflex tears. These are the ones that arrive when something irritating enters the eye. Smoke, dust, a chemical compound like allyl isophyocyanate, which is the molecule that makes onion, vapor, sting. When your eye detects that molecule, the trigeminal nerve fires, the lacrimal gland floods the eye, and reflex tears pour out with much higher water content than basal tears, trying to dilute and flush whatever triggered the alarm. They are defensive, They are not emotional in any meaningful sense. They are the body's equivalent of a fire sprinkler activating. And the third type, emotional tears, psychic tears, as some researchers call them, which is a term that sounds mystical and isn't. These arrive only in humans. Every other tear type is shared across mammals. Emotional tears are not. Dogs don't cry from sadness. Elephants may grieve in ways that are real and profound. But there is no evidence they produce emotional tears the way you do. Emotional tears the way you do. That capacity, weeping because of something felt rather than something threatening, appears to be, as far as science has determined, ours alone. And this is where it gets genuinely strange, because emotional tears are chemically different from reflex tears, Not just slightly, meaningfully different, in ways that researchers have measured and documented. Emotional tears contain higher concentrations of protein. They carry hormones that reflex tears don't, or carry them at far lower levels. Leucine and kephalin, a natural painkiller, a kind of endorphin that the brain releases in stress, shows up in emotional tears. Prolactin, the same hormone involved in milk production, is found in elevated levels in emotional tears. And this is actually one of the reasons women produce emotional tears at higher rates than men in adulthood. They have more prolactin receptors, more of the hormonal architecture that converts emotional state into the chemistry of weeping. Adrenocorticotropic hormone, which the body produces during stress, has been detected in emotional tears. There are manganese traces in higher quantity. The composition is not random. It reflects what was happening inside you. It is, in some measurable molecular sense, a record of what you were going through. Now, hold that thought for a moment. Hold it at arm's length and really look at it. The chemical composition of your tears changes based on why you're crying. Not just the sensation, not just the volume. The actual molecular content shifts depending on whether you are grieving or relieved, or your body is producing different fluids for different emotional states. That is not a metaphor. That is a biochemical reality. And it means that a tear is not just a release. It's a record. Which brings us to Rosalind Fisher, who is a photographer, not a scientist, and who stumbled into one of the most visually stunning scientific discoveries of recent years almost entirely by accident. Fisher was going through a period of profound personal loss. She doesn't describe it in detail in most accounts, and somehow that restraint makes it feel heavier. And she found herself wondering about the tears she was crying. Not in a scientific way at first, in an aesthetic, almost spiritual way. She started collecting tears on microscope slides, her own tears, tears from friends, tears from different moments. She cried from grief. She cried from grief. She cried from laughter. She documented tears of ending and tears of beginning. She let them dry. Then she photographed the residue under a microscope, using light microscopy at relatively low magnification, and what she saw was so unexpected that it took a while for the implications to settle. Each type of tear had left behind a different crystalline landscape. Tears from grief looked nothing like tears from joy. Tears from onions looked nothing like tears from emotional upheaval. There were structures that looked like aerial maps of a city, organized channels and branching patterns, almost like river deltas seen from altitude. Others looked like abstract expressionist paintings, chaotic and dense. Some had clean geometric crystal formations. Some were broken, irregular, unpredictable. She called the project the Topography of Tears, and eventually published it as a book. And when it circulated through the scientific community, the response was interesting, because some researchers were excited and some were cautious, and the caution is worth understanding because it actually deepens the story rather than undermining it. The caution was methodological. Tear crystallization, the structure left behind when a tear dries, is affected by a huge number of variables. The temperature of the room, the humidity, the speed of evaporation, how much blinking occurred, the particular slide used, where on the slide the tear was placed. These factors can all influence the final pattern independently of chemical composition. So when Fisher's photographs show dramatic visual differences between tear types, the responsible scientific position is to note that chemical composition may not be the only or even the primary driver of what you're seeing. And it's fair. That's how science is supposed to work. But here's where it gets more interesting, not less, because those methodological concerns don't erase the underlying biochemical reality. They just mean that the photographs are doing two things at once, and it's worth separating them. What the photographs unambiguously demonstrate is that tears leave unique, unrepeatable physical structures. No two dried tears look exactly alike, even from the same eye, on the same day. That much is simply true. You can verify it yourself with a microscope and a glass slide and a reason to cry, in whatever order those arrive. What remains genuinely scientifically active, still being studied, still contested at the edges, is exactly how much of that visual variation is driven by chemistry versus environment versus chance. And the reason that distinction matters is that if chemistry is driving even a portion of the variation, then the dried tear is encoding information about its origin. It is a physical inscription, a record that can be read, at least partially, by someone who knows how to look. The mechanism behind this is crystallization. And crystallization is one of those phenomena that seems simple on the surface and opens up into something almost incomprehensibly beautiful underneath. When a tear dries on a surface, the water begins to evaporate from the edges first. This is called the coffee ring effect. You've seen it every time a drop of coffee dries and leaves a dark ring rather than an even stain. As the water at the edge evaporates, capillary flow carries dissolved solids, the salts, the proteins, the lipids, the hormones, whatever is in solution, from the center of the drop toward the edge. This is why the edge crystallizes first and densest. But as the water continues to evaporate, the concentration of those dissolved materials increases in the remaining liquid, and at some point, specific molecules hit their saturation point and begin to crystallize out of solution. Sodium chloride, table salt, forms cubic crystals when it crystallizes. But when it crystallizes in the presence of proteins, the proteins interfere with the crystal lattice. Phi get incorporated into the structure. They change the shape, the branching angle, the density, and the density. The same is true for other electrolytes, for hormones, for lipids. The final crystal structure is not just salt. It is salt shaped by everything else that was present during the process. And because the protein content of emotional tears is measurably higher than that of reflex tears, and because the specific proteins differ, the crystal structures they produce differ accordingly. Whoa. There's a field called evaporative crystallography, and it's being studied in clinical contexts that have nothing to do with crying. Researchers have looked at whether dried drops of blood plasma can reveal disease states, whether dried saliva can carry diagnostic information, whether the crystalline residue of various biological fluids can serve as a low-cost, non-invasive diagnostic tool. Nook, particularly in parts of the world where sophisticated lab equipment is scarce. Enter a dry tear on a glass slide is essentially free to produce and does not require refrigeration or centrifuges or trained phlebotomists. If the crystalline structure encodes enough biochemical information consistently enough, you might be able to read a health state from what someone's eye left on a slide. That research is early. Careful researchers call it promising rather than proven. But the direction is real. What this opens up, slowly, if you let the idea breathe, is a completely different way of thinking about what the body produces when it feels. We tend to understand emotion as something internal, something that happens in the brain, in the limbic system, in the amygdala, and the anterior cingulate cortex, and the prefrontal regions that modulate and sometimes suppress what the limbic system initiates. We think of emotion as psychological, real, certainly, not physical, in the way that a heartbeat is physical or a hormone level is physical. But the body does not honor that distinction. The body does not honor that distinction. The body doesn't know that emotion is supposed to be metaphorical. When you are sad, genuinely, deeply sad, your hypothalamic pituitary adrenal axis responds. Cortisol rises. Your vagus nerve changes its firing pattern, which is why grief can feel physical, because it is the vagus nerve connects the brain to the heart, the lungs, the gut, and when it shifts, you feel it in all of those places simultaneously, which is what people mean when they say grief feels like being punched in the chest, or like the air has changed consistency. Prolactin rises, particularly in emotional crying, and may actually be one of the reasons crying feels relieving when it resolves. Prolactin has a calming, almost sedative effect at the neurological level, and the excess produced during emotional weeping may partly explain why a good cry leaves you feeling quieter, wrung out, more settled than you were before. And all of that, the cortisol, the prolactin, the leucine enkephalin, the adrenocorticotropic hormone leaks into the tears. It's not the primary pathway. The kidneys handle most of the hormone clearance, but the lacrimal gland is hormonally responsive tissue, and it secretes into the tear fluid, and the tear carries the hormones away from the eye. And if you collect that fluid and let it dry on a glass surface in a controlled environment, you are looking at looking at, literally looking at, with your eyes, the crystallized residue of what someone was feeling. I think that is extraordinary. I think we should sit with that for a moment without immediately reaching for an explanation or an application or a takeaway. Just, you have produced in moments of your life that mattered a physical artifact of the experience, not a photograph, not a word, not a memory, which is malleable and reconstructed every time you access it, changing slightly each time you access it, changing slightly each time, like a photocopy. A physical, chemical artifact. The grief you felt at a specific moment left a molecular signature, and that signature, under certain conditions, can be visualized. The joy you felt, the specific tearful relief of something finally resolving, left a different signature. Your eye was, in those moments, producing a document. Now go deeper with me for a moment, because there's something about the lacrimal gland that most people have never had reason to think about, and it turns out to be quietly fascinating. The lacrimal gland sits above and behind the outer corner of your eye. You can't see it from the outside. It's tucked behind the bony ridge of the orbit. It's about the size and rough shape of an almond. It receives signals from 3 different nervous system pathways, parasympathetic, sympathetic, and sensory, which is part of why tears can be triggered by such different things. The parasympathetic pathway is involved in reflex and emotional tears, activated through the facial nerve, specifically through a relay in a tiny cluster of neurons called the pterygopalatine ganglion, which is a name that deserves to be said aloud at some point because it sounds like something from a different universe. The sympathetic pathway actually inhibits tear production, which is part of why intense fear or extreme shock can produce dry eyes even in a person who is actively distressed. And the sensory pathway responds to surface irritation, to the trigeminal nerve firing when the eye detects a threat. 3 pathways, 3 different emotional and physical states, and the gland responds to each of them differently, producing tears with slightly different chemical profiles, slightly different protein complements, different balances of the many dozens of compounds that end up in that small volume of fluid. The volume, by the way, is worth appreciating. A single emotional tear is somewhere between 6 and 7 microliters. 1 microliter is 1/1,000,000th of a liter, roughly the volume of a small grain of sand's worth of liquid. In that almost impossibly small droplet is dissolved the full chemical complexity of what your lacrimal gland was secreting at that moment. Proteins, lipids, electrolytes, immunoglobulins, enzymes, hormones. The information density is remarkable. And when it dries, it leaves a crystalline landscape that you could walk across in your mind, like looking at satellite imagery of terrain that was formed by weather you'll never experience and cannot fully reconstruct. There is a researcher named Pierluigi Lullini, and separately there are teams in South Korea, in the Netherlands, in Israel, who have been working on various aspects of tear diagnostics, looking at whether the protein content of tears can serve as a biomarker for conditions ranging from Parkinson's disease to multiple sclerosis to certain cancers. The idea is not outlandish. Lacrimal fluid reflects systemic biology, bapotomy, proteins that cross the blood-brain barrier in small amounts, proteins that are elevated during inflammatory processes, proteins specific to certain neurodegenerative states. Some of these have been found in tears at concentrations that may be diagnostically meaningful. Early Parkinson's research found alpha-synuclein, the misfolded protein that aggregates in Parkinson's affected neurons, and the tears of Parkinson's patients at levels significantly higher than in control subjects. That finding has been replicated in at least 2 independent studies, though the field is careful to note that replication at scale is still needed before tears can serve as a reliable diagnostic tool. But the direction of the work tells you something about what the scientific community believes tears contain: enough biochemical complexity to serve as a window into systemic health states. And then there is the question of the social dimension of tears, which adds yet another layer to this that has nothing to do with chemistry, but has everything to do with what it means that we cry at all. Orhan Hassan, an evolutionary biologist at Tel Aviv University, proposed that emotional tears evolved specifically as a social signal. Not primarily as a chemical release mechanism, though that may be real, but as a visible, honest signal of vulnerability or distress or need, a signal that is almost impossible to fake convincingly because the redness that accompanies crying, the swelling, the loss of articulate speech, the involuntary quality of the weeping itself, these are all difficult to produce on demand in a way that is socially convincing. A cry in this framework is not just a release. It is a communication. It says, I am not functioning normally right now. I am overwhelmed. I need something from you, whether that's comfort, help, or simply the presence of another person who acknowledges what I'm feeling. And the evolutionary argument is that this kind of honest, hard-to-fake signal benefits species that are deeply social, that depend on cooperation and mutual support. And so, over millennia, the signal was maintained and possibly amplified because individuals who could trigger helpful responses from others were more likely to survive and reproduce the environments where survival required others. Which means that when you cry in front of someone, you are doing something that your deep evolutionary history built you to do well, built you to do in a way that is hard to suppress and hard to fake. Because both of those properties, the involuntariness and the authenticity, are exactly what make it effective as a signal. And the receiver of that signal, the person watching someone else cry, also has hardware built for the response. Their mirror neuron systems activate further. Their insula, which processes interoceptive states and empathy, shows increased activity on neuroimaging. Their own stress hormones may change. They are literally built to respond to this signal. So now consider what you are actually holding when you think about a dried tear on a microscope slide. You are holding the residue of an event that was simultaneously biochemical, neural, social, and evolutionary. The chemistry of the moment. the chemistry of the moment. The record of a specific glandular secretion shaped by a specific internal state, the signal that evolved over millions of years to communicate vulnerability between individuals of a social species, the crystallization of all of that, literally, physically, crystallized into a structure you can see, a landscape you can photograph, a pattern that differs based on which specific dimension of human experience produced it. And here is something that Fisher said in an interview that I keep returning to. She said, and I'm paraphrasing her words, not quoting them directly, that what struck her most was not the beauty of the patterns, though they were beautiful, but the fact that each tear was irreversible. Once it dried, that particular tear could not be reconstructed. You could not go back and uncry it, could not recombine the crystals into the fluid and return them to the moment of their origin. Each slide was a closed record. A thing that had happened and left its mark and was now finished, And she said that there was something about looking at those patterns that made grief feel different to her. Not smaller, not easier, but more real, in a strange way, like it had actually occurred, had actually been physical enough to leave a mark, rather than being something that merely passed through her and left nothing. I think that's the part that most people miss when they encounter this science. They get excited about the visual drama of the photographs. And the photographs are genuinely stunning. They look like nothing so much as cityscapes viewed from a great height, or geological formations, or abstract art by some artist who was working with some material that has no human name. But the visual drama is almost beside the point. What matters is the ontological implication, the question of what it means that feeling is physical, that the things we experience as the most internal, the most private, the most untranslatable, grief, joy, relief, tenderness, the particular ache of something ending, these things are also happening in the body's chemistry, in the glands and the hormones and the proteins, and they leave physical records when they reach their expression point. We have always told ourselves that the mind and body are separate in some meaningful sense, that the physical world and the felt world occupy different registers. And that story has been useful in some ways. It lets us talk about experience without reducing it to mechanism. Lets us speak of love as something other than oxytocin. Lets us say that grief is more than just cortisol and prolactin without feeling like we're lying. But the tear science whispers something different. It says that the separation is not quite as clean as we've insisted, that when you feel something deeply enough to cry, The body does not merely accompany the feeling. It participates. It produces a different chemistry, a different secretion, a different residue on the physical world. And that residue is not incidental. It is structured. It is patterned. It carries information about what produced it. It is, in the most literal sense, available to us as a record. Think about everything that has made you cry in your life. Not as a catalog. You don't need to list them. Just as a vague acknowledgement that there have been moments. Some of them were losses. Some of them were things finally resolving after too long of not resolving. Some of them were beauty, the kind that arrives unexpectedly when you weren't prepared, and the thing, a piece of music, a particular light on a particular afternoon, a stranger doing something kind when they didn't have to, exceeds whatever threshold, separates moved from overwhelmed. Some of them were relief so profound it felt indistinguishable from grief. Some were physical pain or the end of pain. Each of those moments was also a chemical event. Your lacrimal gland was doing something specific in each case. And if you had collected those tears, if you had been in a strange position of knowing at the moment of crying that you wanted to save the residue, each one would have dried into a different landscape, chemically different landscape. A private cartography of what it has meant, physically in your body, to go through the things that made you who you are. That is not poetry. It is biology. Or, although maybe, at this particular intersection, the two things are doing something close to the same work. There is one more dimension worth sitting with before this whole picture closes into something you can carry with you. The fact that emotional tears appear to be uniquely human, or very nearly so. A few researchers have proposed that some other primates may produce emotional tears in extreme circumstances, though this is not well established, raises a question about what that uniqueness signifies. It is common when we discover something unique to humans to immediately construct a narrative of superiority around it. But I don't think that's the right frame here. Because what does it mean to be the species that weeps from feeling? To be the species that weeps from feeling. It means that the complexity of our inner life eventually exceeded whatever threshold keeps internal states internal. It means that what we feel became, over evolutionary time, too dense, too intense, too socially relevant to stay invisible. We developed a whole system for externalizing the internal, a system that is glandular and neural and involuntary and honest, that cannot be fully controlled and cannot be fully faked, that leaves a physical residue that is chemically specific to its emotional cause. We are the species that leaves marks when we feel things. That is not grandiosity. That is just what the biology says. And maybe that's why we've always known, in some intuitive, pre-scientific way, that tears mean something, not just the social performance of them, not just the catharsis of them, but the fact of them, the fact that a specific thing was happening inside a person and the body decided, or was built to decide, that the right response was to produce fluid from a gland behind the eye and let it fall. Every culture has a mythology of tears. Every literature has tears in it. Every religion uses tears as a marker of genuine encounter with something real, with the sacred, or the tragic, or the finally understood. We have always treated tears as a threshold as the place where inner life meets the physical world, as evidence that something real is happening on the inside. And it turns out we were right. Not metaphorically right. Not metaphorically right. Chemically, molecularly, crystallographically right. The threshold is real. The encounter does leave a mark. The something real that is happening on the inside is also simultaneously happening in the lacrimal gland, in the protein concentrations, in the hormonal milieu of the tear fluid, and ultimately in the crystal structure of what is left behind when the water evaporates. You have been leaving these marks your whole life, on pillows, on sleeves, on skin of people who held you, on glass maybe. If you've ever stood at a window crying, which people often do without knowing why. Something about the transparency maybe, or the outside world continuing in its indifference. Everywhere a tear has dried, there is or was a crystalline record of a moment that mattered. Most of those records are gone, wiped away, washed, absorbed into fabric or air. But they were there. They were real, structured, specific documents of specific moments and a specific life. They were the body's handwriting. Look at your eye the next time it produces a tear. Look at it not with embarrassment or with a reflexive wish to suppress what the body decided to do, but with something closer to curiosity, something that knows now, if not before, that the gland behind your eye is doing something chemically specific, something that reflects what you're experiencing, something that will, if left dry, in a quiet place, leave behind a pattern that does not look like any other pattern ever produced by any other. In any other moment of any other life, you are always, in some sense, writing. You just didn't know what medium you were using.